Okay, we're going live on YouTube.
Do you need to
And
come? And we're live. Okay, thanks a lot, Bhumika. Thanks a lot. Okay, good evening. Welcome, everyone. We're starting our last workshop this year. I just realized it's already December and almost Christmas. So it's our final gift for you this year, I would say, from PyLadies Amsterdam to everyone. So, what's going to happen today? Today, we're going to spend some time being busy with our workshop. And before we start, just a couple of simple rules. So now we are live, the streaming is going on. If you have any questions, there is a Jitsi chat where you can ask your questions. There will be 3 major breaks during the workshop where you can literally like bundle your questions and then I'm going to answer them. If it's something really, really critical, feel comfortable asking it right ahead. Only small thing that we're asking, make sure that your mic and camera is off during the workshop to prevent any terrible noises coming from there. So I think that's it for the setup. To start with, for those who is the first time with us, welcome. For those who not the first time with us, welcome as well. We are PyLadies Amsterdam. We are local chapter, one and only Dutch chapter from Global PyLadies Group. We acted on diversity and technology, and although our group is open to literally everyone who's interested in Python, it doesn't matter, let's say, gender or anything other related who you are, we aim to give a podium for workshops and really rarely for talks for mostly underrepresented group. So if you're struggling, should I join the next workshop? I'm allowed to join. Yes, of course, you're allowed to join. Only one thing, we are going to make sure that literally we're giving this podium for underrepresented groups. So yeah, let's start. You're here today for this model diff workshop. I would say it's an introduction. So if you do expect to become MLOps professional after the end of this workshop, I would a little bit disappoint you. It's not going to happen so quick, but at least my goal today is to make sure that you get a proper understanding of this concept and you have some real hands-on examples how to start doing this. So that's the goal for today. So that's what is expected. I start with a short intro about who am I and the things that are necessary for this workshop setup. And then we're going to cover 3 major topics. So we're going to take a look at the model performance and how to measure it. We're going to take a look at handling the drift. We're going to discuss different type of drift today. And we're also going to take a quick look at test-based monitoring, what it is. And then we'll round up with some closing remarks. And between each part, so between model performance, handling the drift, and test-based monitoring, will be exercises and time for the questions. So who am I? My name is Alyona Galyeva. I'm co-organizer of PyLadies Amsterdam. During the day, I work as a principal machine learning engineer at Thoughtworks, also Microsoft AI MVP. And literally what I do, I helping people with making sure that their models brings value to the end users of these models. I also do some data engineering and data strategy in addition to that, but my core focus is literally setting up MLOps and making sure that the company could scale up their data science capabilities. There are some nice pictures of our PyLadies Amsterdam workshop before COVID. Then as soon as COVID started, we switched fully to online mode. And now from time to time, we do hybrid session. So the majority of our workshops will remain online, but some of them will be held hybrid. So yeah, let's start. This is a workshop setup. I would ask my colleague, another co-organizer, Bhumika, to share the link for the workshop with everyone. And there are some README instructions that I want to point your attention to. So thanks, Bhumika, for sharing. So this is literally the requirements for the workshop. It's just the README page, what I mentioned about. So In theory, everything from Python 3.6 or higher should work. I did personal testing starting from 3.8. So we're going to see how does it work. I also set up everything for Visual Studio Code, literally just Visual Studio Code with Python extension, nothing extra to it. And standard way of doing this, just clone this repository, navigate to its root, and install the required libraries. Of course, the best way to do it, starting creating virtual environment and installing these libraries there. As soon as this will be done, there are two steps that have to be done before starting with this workshop. And this is literally running these two commands that I'm pointing out right now, because what's happened there, after this command is used, it will install the evidently NB extension, notebook extension, and evidently this is the library we're going to work today with. And another line, we're going to activate it. And as an additional side note, that there could be some issues with how the widgets are working. So if it's, for example, Jupyter Lab, it could have some really strange things in the notebook. But anyway, the functionality to save the reports as HTML should work, and we're going to explore it later. And I think the last part regarding the settings, I could share eventually the workspace setup of VC Code. When I was testing it on different systems, I realized that it doesn't work on all systems. So one thing that is necessary to do, I will show you where it is literally, it's to fulfill this step. And this step literally allows you to point the Jupyter notebook to the proper execution folder. That's, I think, the bare minimum that should be done. It's up to you to do things at the same time as you're watching, or just to watch right now and then get back to it later. So it's your choice how to proceed further. And there is also a side note for Windows users. So with Windows users, there could be as well some issues because the way how evidently create the HTML report, it uses Symlink, and on Windows machine, you have to have an administrator role to do this. So this could be the note for Windows users. So regarding this part with Visual Code settings, I just show you where it is, and then we literally move to the continuation of our workshop. So this is my Visual Studio Code setup, and here literally you have the settings button. In the settings button, you have these two options, user and workspace. If you apply anything for user, it means that it will be done for everything that you have on your laptop. And if you just want to use it for workspace with your workshop, I highly recommend to do only specifically for your workshop. And this is what I mean by that settings. Then you go to workspace. Here's your workshop opened. And literally here, you're just looking for Jupyter root. Yes, so here by default, it uses file directory, and you should replace this with this value. It means that in this case, your workshop is in this folder workshop, but while running everything in Jupyter Notebooks, it's going to run it not from this folder, but it's going to run it from this folder, which we need today. So this is the basic setup. I will switch now for the theoretical part, and then we can continue with the workshop per se. So let's start with why we need the monitoring and why monitoring for machine learning use cases is so hard. So if we are living in the world of traditional software, let's say that as soon as you deploy something, it remains as it is. I don't talk about bugs right now, but I just talk about there are some specific piece of code that you deployed, and if nothing changed, it continues delivering value that is eventually expected. And I will let my cat out, so stay with me 1 second. Yep. So now the cat will know nothing about the AI software, unfortunately, but you will. Okay, so in the traditional software, there are DevOps team that usually responsible for monitoring of the application or whatever you're running in production. And they usually are looking at specific components. So the question is how the AI software and they're different. If we take a look at the AI software, this is unfortunate what happens if you do nothing or if you continue to apply traditional software approach to machine learning. So what's going to happen? Your model, so in this case, it's represented by this beautiful yellow lemon. So your model will degrade. The question is how quick it's going to degrade. Depends on a lot of factors. Sometimes it could be years. Sometimes it could be months. Sometimes it could be days or even hours. So what means that if you want to make sure that your machine learning model works securely and delivers what is expected from it to be delivered, there should be some additional layer of monitoring added. And the hardest question is, who is going to do this? Because usually the DevOps teams or software engineering teams that get to use to traditional software, they frankly speaking have no clue how to monitor machine learning models. And what we see in the majority of the companies, that the experimentation part and proof of concept takes place in the Jupyter notebooks, then the code's extracted from these Jupyter notebooks, then the code packaged in one of another way, and then the code literally deployed by DevOps teams or other software engineering teams that has or really less experience or little experience or even no experience working with ML. So what we're going to discuss today eventually is how to monitor machine learning models, when to retrain the machine learning models, and in which cases you need to remodel this. And to answer the question, who is going to do this? Guess what? This will be the work of data engineers, data scientists, and machine learning engineers. So in this case, imagine scenario, you have a model that's deployed, for example, as Fast API. Fast API, it's Python app that's, let's say, deployed with the help and running on Kubernetes cluster. So in this case, the basic telemetry, whether the cluster is running or not, whether the load balancer working or not, will be handled probably by DevOps team, but the monitoring specifically to the model, which is what is the data input into the model, what's happening within the model, and what happens with the predictions of the model, this will be monitored by dedicated data scientist, machine learning engineer, or sometimes a data engineering team. So that's in a nutshell what you need to know to begin. And now it's time for us to switch to literally our workshop. Oh, before that, I think the most important part as well is just briefly mentioned what kind of open source Python library we're going to discover today. So the whole workshop today is about usage of Evidently library. As I mentioned already, it's an open source Python library. It was originally created and designed for data scientists and I would say machine learning engineers in need. And literally the major tasks which this library do is evaluation of the machine learning models, its proper testing of machine learning models, and performance and monitoring the performance of this model. So for now, Evidently comprised of 3 blocks. We're gonna discover today 2 blocks. It will be tests, which more, I would say, designed to be used in production, mostly for batch use cases. And we're gonna spend a lot of time investigating reports today. We're not gonna spend any time on real-time machine learning monitoring for one and solely reason, because it's in really early development right now, which means that API could oversee really drastically changes and a lot of things gonna be broken. So we're focusing on reports and tests. And with these instruments, you can see what you can achieve if you start using this Evidently library. And of course, for those who are interested in contributing to it, there will be some guidelines how to do it at the end of the workshop. So, and now just moving to workspace folder. No, I'm not changing this. I'm just going to my, of course, not this one. Yep. Then I'm just activating my environment. Okay, great. We have everything already imported. And what I'm doing right now, I'm just going and opening this workshop notebook. So the goal of this evening is to work with this workshop notebook. There are some exercises on the way. And yeah, that's what we're going to do today. So I will start by running the first cells. So this is just standard import statement that you used to see. We import in pandas, we import in sklearn because we're going to use the datasets from sklearn today. And we import a lot of stuff from evidently. So we import column mapping. We're going to discuss this later. We import the report. We import specific presets for the reports. This is to cover the first and the second part of our workshop. And we also import specific values for test suite and specific presets for test suite for literally the third part of the workshop. So now let me run it. Yeah, okay. So basically, what's happened there, I just commented, I'm going to run it and just comment on the go. We're going to discuss today two options, both which covering supervised machine learning tasks. And we're going to discover classification and regression. Classification task I'm going to show you, and the regression part, it will be your contribution to this workshop today. To show you how evidently looks like and how it works, first of all, of course, we need to have a data, we need to have a model. And what's happening there, I'm just, for classification use case, I'm importing iris data from sklearn datasets. I immediately transform them to the pandas data frame. Then I split data into two, let's say, categories. I call them ref and car, which stands for reference data and current data. Or you could say reference data, you can call it as a training data, and current data, which means production data. Then literally I just using train test split to split this data in specific chunks. I initiating and train the random forest classifier, and then I generate predictions and making sure that these predictions are added to the data frame. Word of notion here that currently evidently supports only work with tabular data, and this is work with pandas data frame. I've heard that on the roadmap, there will be probably Spark data frames in the future, but for now, it's only limited for tabular data frames. So think about when we talk about tabular data, think about the table, which literally a pandas data frame. And that's what we're going to work with today. And for specific use cases, we need dataset, which literally has doesn't have predictions added to it. So literally, I also create two variables where I save only input data without predictions and the targets. So if you can take a look at it, if you want to look at it, how does it look like? So for our iris use case, just to see what's the difference. So for example, we have this current iris data, so which has these two columns, target and predictions. And in case with this input data, you see the same literally, but without target and predictions column. So that's the difference. So what I did so far, I just literally load the data from iris data set. I just split this data. I trained a simple random forest classifier, and I created 4 data frames, 2 data frame, which are responsible for having the full data set together with target and prediction column. And part of them dedicated to ref data, which are trained data, the data where the model was trained on, and the rest is framed as a current data, and we treat them as a current production data. And the same story, exactly the same story happening with California housing dataset eventually. So nothing special, again, getting the data, renaming specific columns, splitting the data, because the data set is pretty big, I would say, to make sure that we are using our time efficiently. After splitting, I just sample 5,000 and 1,000 examples from each of them, and literally, again, training random forest regressor, creating, calling model predict to get additional prediction and target column, and literally also creating separate data frames without target and prediction column. This is just basic setup to show you the functionality of the evidently, which is the topic of our workshop today. So what we're going to do right now, we're going to discuss the model performance and how evidently allows you to have out-of-the-box generated reports. So we're going to take a look right now at the concept of column mapping, which is one of the core concepts, which is used by evidently for almost all use cases. And then we're going to take a look at literally usage of pre-built reports, one for classification model performance and one for regression model performance. So what's happening here? The concept of column mapping. So as I mentioned, evidently works with tabular data, which means that the tabular data in this case is a pandas data frame. If you're not going to use the column mapping, it means that evidently by default going to try to do mapping on its own. What does it mean by mapping? Is assigning the name of each column and also assigning the specific data type. But it's not going exactly to specify in the Python or pandas data frame data type. It just literally trying to split data based on whether it's numerical or categorical. That's it. So in this case, column mapping is pretty important because with column mapping, you literally pointed out to the evidently how to treat this data frame in the proper manner. So what's happening here? I created just a column mapping object. Then I list categorical and numerical features. In our case, with Iris dataset, we do not have categorical columns. We have only numerical columns. We just list the name of these columns here. And then we are pointing it where the target, so they know the target is. Why it's important to do this? Imagine, for example, that you work with, I don't know, like Facebook profits, which usually has two columns, DS and Y. So in case, if you don't point that Y is your target column, it can get confused. That's why we're just literally pointing out that for this use case, for our Iris model, for our Iris data set, these are the numerical features. Then there are no categorical features. Then there is a target column, which is target. And then there is a prediction column, which is prediction. Additionally, because if you look how the prediction for Iris looks like, it's just literally 102. And if you want to have more vivid and nicer graphs, literally the visualization of it, instead of seeing 0, 1, 2, you can literally pass the target names in the proper order. So we know that this proper order is Setosa, and then it comes forward. So in this case, you can also pass a target name. And the last thing is literally column mapping task. So by default, evidently also trying to understand whether it's regression or classification task, but based on their documentation, they said that it's better to say as much as possible during the column mapping, and then it will allow you to get all reports generated in the proper way, because you know it's the data frame you used to work with. You know exactly what kind of columns there are, which columns are numerical, which columns are categorical, what is the name of the target column, and what is the name of prediction column, and what kind of task you're using. So now I'll give you a couple of minutes, I would say 4 minutes max, to try to go with your first exercise. After that, I will literally type the answer for this exercise, and this will be to do column mapping for your regression model. Because for Iris, it's already done. I just call it column mapping, but for California housing dataset, it's not done yet. So literally what needs to happen, evidently, has to know what are the columns with numerical features, what are the columns with categorical features, what are the columns with target, what are the columns with prediction, and what are the task. One thing that's going to make your life simple, instead of calling the data frame and listing the name of all columns of it, you have already some help done for you, and literally you have already a numerical features rec value here. And this numerical features rec, it's literally the list of all necessary numerical features or numerical column names. So you don't need to type it by hand, it's already there. And I can just check here, numerical features. Yeah, so this is literally how does it look like. That's what I mentioned, numerical features registration. You already has all the names listed as a list. So take your time and then we'll see how to do this mapping together. Okay, so for those who are already done, it's great. If you're not done yet, it's okay. Sometimes it's just, we just started, it's the first exercise, so bear with me. So what I'm going to do right now, I'm going to literally create in the column mapping for our regression model. So let's call it column mapping. So literally what I'm doing first, I'm just creating the column mapping object. This is the first step. Then the next, I need to map numerical features and categorical features. If I go back to this housing data set, literally we don't have any categorical features, which means that we need to map only numerical features. And it's what is expected. Literally, the list of numerical features is expected. And as I mentioned before, numerical features reg, this is exactly the list that we are looking for. So reg column mapping, and then just add some numerical features. And the numerical features is, okay, numerical features reg. numerical features reg. Okay, so now categorical features. Next step, what I need to map? I need to map the target column. Right, column mapping, target, and in our case, the name of it is target. And now I need to map prediction column as well. So right column mapping, prediction is prediction. Here need to be cautious what we are typing to. And the last thing is to map the task, which in our case, here we had classification, and in this case, we're going to use regression. So column mapping, task, and task will be regression. Okay, let's run it. So you see here that I just keep target names because it's a regression, so we do not have target names eventually. We predict a number. That's why this 5 lines, will be enough. So why we did this? Because without column mapping, the reports could be generated in incorrect way. So now it's time to switch to this classification performance report. You're going to see what it is, when to use it, and how does it look like, and also what kind of customization is applicable for this report. And of course, you will see, I will open the reports map to make sure that we're going to see when this will be generated. So the performance reports usually could be generated or using 1 data frame or using 2 data frames. And if it's 2 data frames, then you have your training data, or as we call reference data, and then it requires another data set, which is your current production data. So literally you want to see how your model performs on the real, let's say on the real production data right now. Now this classification performance reports work for different types of classification. And also what you're going to see eventually on the screen, you're going to see different metrics plots, and usually it's work in progress. When I was first starting just using Evidently, it has like 5 or 6 components. Now they make it bigger. And why do you need this report eventually? So report is not really suitable for production stuff because it literally generates a huge HTML file, but this is really nice thing for debugging or while you're developing your model, or if you want to compare the performance of, for example, 2 models to decide which models to promote for production. So as I mentioned, you need to run this report, you need these 2 data sets. Also make sure that both data sets has the target and prediction columns available. That's why I was adding this target and predictions columns from the very beginning. So let's see how it looks. I will just scroll. This is more information for you to read in your spare time. But let's see how does it look, how it's generated, and what's inside of this report. And also what type of customization is possible for this one. So if you showing target predictions and all input features, it can help you to show the classification performance of the model. And you can even explore how the model, what's, let's say, the relations between specific features and targets. So in case you want to customize it, you can do it for specific subset of columns, for example. You also can change specific parameters. For example, there are metrics, you will see it in a second, specific metrics they calculated. So if you want to, for example, to pass or to update the decision threshold or something like this, this is possible. Different colors also possible. Only one thing, if you want to exclude some of the metrics, you say, I don't need all this 10 pieces of it, then you need to create your own custom report. And how to do it, it will be probably the topic for the next more deep dive workshop. Together we just get familiarity with it. So for classification model, we just literally creating the report. We pick up metrics for this report, which are eventually presets that's already developed by Evidently. And you see that's when I just hovering around above it, it shows what exactly it's going to show you. And then I just need to run this report. So to run this report, you need these 2 data sets, the reference data set, which is the reference data or training data. You have the current data set or like production data. That's the current data. with target and prediction columns. And this is where the column mapping starts playing a role. So here, the column mapping, we pass in there the proper column mapping for the classification task. So when I just call it, it's quick, it's done. Now the next thing, by default, you are thinking that, oh, if I want to see it, I will just gonna say classification performance report, just show me it. I show you what's gonna happen if you do this. If you say classification performance reports and you will expecting that is gonna be shown to you, that's the results that you get. It will say loading and it's gonna keep loading for ages. To make sure that you don't have this issue with loading, use this show method, and the mode that should be used is inline. So let's call it. So now we see our reports generated out of the box. It contains different parts of it. So let's see, I do hope that it's like gonna look normal. So I have currently model metrics that we have. For the current data, it's like the production data that we have. Then for the reference data, then we have class representation, so number of objects. Although we passed the target names, it's still treated here as 0, 1, 2. There are some stuff, it's all interactive. So that's what we get. Then it's also generate confusion matrix for you. So the current data, reference data. Again, everything is interactive. And then it's generate quality metrics by class and by feature. Here, the search is interactive. And for example, if you pick up petalent, you see here it picks up the names, the target names, and here it doesn't pick up, unfortunately. But anyway, it's still work in progress. Here you can see the features and you can see specific things, which shows you, for example, true positives, true negatives, false negatives, and false positives. So literally, there are a lot of things already out of the box. That's the beauty of report preset. And now there is a possibility to save it. And you can save it as an HTML file, and you can save it as well as a JSON. I'm more a fan of JSON because if you have JSON, it means that probably you can use it, for example, like a Grafana dashboard or something, and that's what you expect to get. But as I mentioned, this part, so reports are really well suitable for development and for debugging. So if something went wrong in production, probably the alarm will be triggered and it will send to, okay, this is probably what causing the issue. And then you can literally generate quickly get samples of data, generate this report, and visually try to visually debug what's going on with the performance of your model. Word of caution here, though, if your data set is pretty huge, we're still working with pandas data frame. It's not in Spark data frames. And for example, you're reading it by chunks because let's say the whole data set doesn't fit in memory. The generation of reports could take, I would say, a specific amount of time. When I mentioned with California housing pricing, when I was just experimenting with it, if you try to do it for the whole data set with more like 50,000 samples rows, then you get, it's like you need to wait 20 seconds until the HTML file will be generated for you. So now let's take a look what it is. So I'm just gonna take a look at it here. So this should be the same report that we seen before. Yes, so this is the same report that you see before, confusion matrix. This is literally HTML that is generated. So with all classes next to each feature. Yeah, so this is what you get out of the box. I mentioned some of things could be customizable. For example, thresholds for specific metrics. But if you want more customization, then you can create your own report. And for now, what has to be done, it's regression performance report. So the same story, a regression performance report could be done for literally for one of your model, or for example, if you want to compare two different models that you have, one that is currently running in production, and you want to know whether retrained model is better and it's time to deploy it or not. That's the way when to generate, for example, this regression performance report. As you could guess, again, it generates a variety of metrics and plots, but they will be, in this case, more related to regression task. And it helps you literally to explore areas, for example, under overestimation. So here again, there are different things when can you use this report. It could be used in combination with other different one. So to run it, you will need, again, these two data sets, and each data set has to have a target and prediction columns available. So that's kind of things that's going to be generated. Again, report could be customized. And what I need you to do right now, and I give you for this as well 5 minutes, is to create a regression performance report. Only one thing, so let's double check whether the preset is there. So report is there, great. Metric preset, we have classification preset, data drift, data quality, target drift preset. Just a quick hint, if you want to use regression preset, you need to import it first. So don't forget to import the regression preset. So I will just scroll it down for here. Then we have this 4 minutes, 4 or 5, 4 already. And we walk further. No, it looks like my screen is not shared yet. Just a second. Yep. Good. Yeah, okay, it's back. Okay, so let's generate the regression reports. As I mentioned, we need to import preset first. Let me just scroll back here. So I will just add the regression preset here, and just to re-import again. Yep, we got it. Then go to regression part. So okay, Now I want to create this regression report. Let's call it, yes, like performance report. So I need to have report, then report has metrics, and this it expects a list of metrics. In our case, the metric will be this regression preset. So regression preset, I need to call it, great. And then I need to run it. Regression performance report, run. And to run it, I need to specify on what I want to compare with what. So I have this reference data, which in my case, this is, I just wanted to type housing. So it will be this housing ref, that's just it. Then I have current data, and it will be housing current data. And again, concept of column mapping here back. And this will be our regression column mapping. So now I'm just run it. And now I want to show the report. Remember, if you just type regression performance report and try to run the cell, it's gonna keep loading. So let's do this show. And then the mode should be inline. Let's see. Yeah, okay, so that's, we get this out of the box. In this case, now we have metrics, which is dedicated to regression. Then we go some pretty nice graphs of actual value versus predictive value, where you see in the current data set and you see the reference data set. Then you have predictive versus actual in time. So there are different ways how you can sort it. By default, it picks up sorting by index. If you have a data time column, it's gonna literally sort by date time. So in this case, it will be change of the value in time. So we have again predicted and actual. Then we have errors, predicted actual, absolute percentage error. All graphs, as I mentioned, they are interactive, and we as well have our error distribution. And there are a lot of other goodness with error bias table and everything that you can imagine. It's all there showing you where your model is underestimate, overestimate, and where the majority of data points coming in. And here, what is nice, again, that's each part is clickable, and literally the reports. And just let me save it. So it was regression performance report. I want to save it as HTML. And I'm just gonna grab this and put it here. And then for the JSON, I'm gonna do the same with path, and I'm just gonna put it there. So just let me save it, run it. Okay, now let's check. Oh, it's classification. We don't need classification. Let's check this one. Okay, and now you get your report with all the things, and it looks, yes, because in the Jupyter Notebook somehow this names of columns were lost. Here you get ref stands for reference data and current starts for current data. So let's sum up this part and before moving to the next one. So we just started working with Evidently library. We just investigated the basic reports, and basic report is the classification model performance report and a regression model performance report. That's what we've done so far. Each report could be used for development purposes and also for debugging purposes. If you want to do the same, it's also possible to do in a test way, but this will be the third part of this workshop. And it looks to me that there is a question. Okay, this time yet. Okay, good. Thanks, Vilmika, for the chat. Okay, so that was just the first part. You said, okay, Alyona, great. I know how to do like this, let's say, model performance, and I don't need any fancy reports from your side. I can just generate it basically with like Plotly in my Jupyter Notebook. Why should I care about this? Why it's important? And what's differentiated then evidently from, for example, just like Plotly library. So in this case, when we move to the drift part, this is where the evidently starts to shine, and as well it's a test part. So here, so when we talk about drift, I want you to remember that there will be always, in general, 3 categories of drift. There are more, but let's put into 3 buckets. So the first bucket will be data drift. And I would say this is what usually is the cause of model degradation, because the data are changing. Second is the model drift. So think about like everything that happens in between. And the third is literally like the output model drift. So in this case, how the target's gonna change in time. And just to give an example of all these different types of drifts and why it's hard to handle, usually handling of such type of drift requires specific efforts from the side of data scientists, data engineers, machine learning engineers, because usually I'm not saying anything bad about DevOps people, but their core job is a little bit different than decide on which algorithm to apply to compare 2 data distributions, for example. So the hardest drift to monitor is a data drift. Why? Because usually it requires extra infrastructure efforts. The target drift, this is probably something that will be there. And this, I will get back to questions in a second. And okay, sorry. Okay, yeah, we're here. So with this target drift scenario, usually we have a space where we store the targets so we can get back to them. That's why usually when the company just starting with model monitoring, they just started first with basic, literally monitoring the model performance, as you just see with this, like 2 reports, for example, and then they start to implement target drift, probably some model drift, and at the end, they focus on the data drift. However, there are use cases where the data drift monitoring is easy to set. It depends on the way how your model deployed, on all these components. And just to give you an example of data drift, imagine that you have a model that try to predict, let's say, the amount of cargo containers that's going to be received from China. So literally, that's what your model was trained on. And as soon as the COVID started, there was nothing coming from China. So literally the import from China was stopped completely. So in this case, your model your model still predicting that there will be containers, but in fact, there was no. So could be as well as a model drift scenario that mapping between the incoming data in which you try to predict is changes. For example, the housing prices for a specific region, and then, by the way, there is a metro station that's got there. So your model never such prices in this region, and it learned that this region should be less priced. So that's, let's say, the different types of drift that we're going to learn how to handle today with the Evidently library. And I will answer the question. So how do you split the data into training of model and validation data? So if it's a question about this workshop, we're just using here the, let me scroll to the very beginning. I just use like basic scalar model selection train to split. If you mean how to split the data in training model, sorry, probably I read it in a wrong way. So here I'm showing like the child way where I'm just like taking really the whole Irish data set. I just split it in 2 components into the training. So there is no validation, nothing. In the real life, you will do definitely, you will have your first training data, which will be split into training data, into validation data, and the test data, which allows you to validate different types of models, and then finally to test the best model. So this part will be treated as the reference data, and the current data, this will be the data that's coming from, for example, from your production system right now. That will be the split. If I answer a question, if not, let me know. Okay, so we just saw that there are different types of drift. And when we're talking about monitoring and acting upon it, first we need to detect it. So what's nice about Evidently already has some pre-built reports for you. And we're going to take a look at this pre-built reports right now. So a lot of scrolling. Yeah. So what we're going to take a look today, we're going to take a look how we could spot the drift to act upon it. And when saying act, when you noticed, for example, that there is a huge change that the drift is detected, then there should be specific action following. It should be our investigation, what exactly changed, or it should be an alert to trigger some specific automated process. So it's not just about detecting drift, but also decide the strategy on how to act on this drift. Or do you need more investigation, or everything is automated and it just go out of the box? So for handling the drift, we're going to take a look at data quality, data drift, and target drift reports for now. So what's nice about this data quality and data drift, they do not need any predictions or targets. So literally they only looking at input data. If we talk about data quality, think about it as a fancy way of visualizing pandas data frame describe. You're going to see how does it look. So it's literally looking for missing values and all that. You will see it in a bit. And then also the data drift. So literally the input data that's coming in, and target drift. So for data quality, it could be single data set or two. We're going to use two because we want to compare, in our case, this, let's say, training data set, and then we want to compare the current data set. What it's going to do for us is going to calculate all these basic statistics and then create this interactive plots. So it's all instruction, how it looks, how to do it, how to run it, how to customize it. Again, the reports could be customized. If you want to add extra metrics, it will be a custom report. Now we're taking a look at the basics. So to do it, to generate this data quality report, again, you call in reports, you call in the same metrics preset. In this case, you're going to call for data quality preset. And here we don't need target and predictions. We just need an input data. That's why iris reference input data and will be literally the reference data, and iris current input data will be the current data. And again, column mapping is here. Then I just want to save them and to show you. So let's just run it for now. Okay, so this is eventually how it looks like. It gives some feature warnings so we can discover it later. So you get your dataset summary with, okay, what's the column? It says, yes, of course, we don't have target or prediction column right now. There is no data column as well for iris dataset. And just give us a description of what's there. And literally then it goes through each feature and shows specific basic statistics on its feature. So we have 4 features with iris, and that's what we get. Here, what's nice, you have this linear scale, log scale, so you can change it if you prefer to see it in a log scale, for example. So each one of them is here. Then you get missing values. Here there is no information because we, in this case, we do not have any missing values. And there are also correlation metric. Now I see it still doesn't look really nice here. So let me just open this part for you and make it a little bit bigger. Yes, okay. So this is the dataset summary that you saw. And here you get as well correlation metric. You have different options. So one of them are worth using for example, numerical data. Another one worth using for categorical data. That's what you get out of the box for the data quality report. Where it could be used, again, it could be used for basics debugging. If you want to use it for production, we're going to replace this report with a test preset. It's almost the same, but more lightweight. And let's take a look at the data drift report. So a data drift report requires specific drift detection method. There are different methods, different algorithms for detecting this drift. It's different for numerical features, different for categorical features, and it's also based on the amount of data points that we have. So there are specific thresholds on which one or another algorithms are used literally. So In this case, I will just generate it for you. Again, with this custom, there are more information about what kind of customization there. You can explore it later. The same story. We just create a report. We use metrics and we use data drift presets. We don't need here targets and predictions. We just need the input data. That's it. So reference data is our iris reference. Input data without target and prediction. Current data, it's our current input data without target and predictions, and the column mapping. And let me just run it. And I will open it here to make sure that it's more beautifully looking in the browser. So that's what we get. First, what we see immediately, data set drift is not detected. And here you see that threshold for data set. So Bhumika, just let us know when we can continue.
Yeah, we're good to go.
Okay, thanks, Bhumika. Thanks a lot for support. Okay, so I was talking about how the data set drift report looks like. I was saying that in this case, it said it's not detected because we have this threshold. You can change this threshold. It's up to you to decide based on your data what kind of threshold is going to make sense for you. Here it says that, okay, drift is detected for 0 columns. You see here not detected. Here you see also the literally the algorithm that it used. It's Kolmogorov-Smirnov p-value, if I'm not mistaken, and the drift score. And what's nice, here we have all our features. So for each feature, we can take a look at data drift, and we can also take a look at data distribution. And you see comparison with current and reference, current and reference. So this part, let's say in green, the dark green line is the mean, as seen in the reference data set. The green area covers one standard deviation from the mean. So it's more for you to investigate and to take a look what's there. What is also the use case for this one? So imagine that you decide that your model, it looks like your model required to be retrained every week. So before literally retrain this model, it's much more easier to run this test, to run this dataset drift. And if you see that based on your setup threshold, the data drift is not detected, then what is the added value of retraining your model? So in this case, you can find the sweet spot of retraining your model often enough to get really good quality predictions. And at the same time, making sure that the, let's say, that you don't gonna burn compute resources for retraining your model if it's not necessary. So this is what you can get out of the box with this. Yes, and the data drift per each feature, and shows you per each feature eventually. And the last one is the target drift. So the target drift, again, do the same thing as a data drift. It's also perform specific statistical test to compare or targets or predictions distribution. Which algorithm is chosen, it depends, again, on the amount of data points and what kind of targets do you have, and literally when to use this report, again, to know whether it's worth retraining your model or not, and to make sure that your model performs as expected. So here, same construction. Again, you have report as a base, you have specific metric, and from this metric, you pick up this target drift preset. And target drift preset requires target and predictions column, or targets or predictions column. That's why here, when I run it, I pass it the data with predictions and targets, and here as well, and the column mapping. So let me just run this report. And now so it was target, regression, target, class target drift. Okay, it's this one. So just me open it. Yes, so this is a target drift. So what you get, it says the data drift is not detected. Then it's point out which drift detection method what use. Again, you can change it. So you can define specify which detection method should be choose. And then it shows you literally the data distribution. Here it was for column targets. And now we're looking at the column prediction. It says again, the data drift is not detected, and this is the score. And then you have target prediction behavior by feature. So literally you can understand what will be the influence each feature on your target and your prediction. And you get here prediction labels. Unfortunately, it doesn't show you the names, it shows you only the numbers, but I think it's still great. And it's all interactive, so you can play around with it. So now, guess what you're going to do next? Surprise, surprise. And now your task will be to generate these 3 types of reports for the regression model, just to see whether there are any difference for the regression model. And yeah, that's what you're going to do the next. I would, for now, block it for, let's say, for 4 minutes to make sure that we can sum up this part and take a quick look at the test-based monitoring, which is pretty important if you want to use it for production. So yeah, let's do this. So I would say at 40 minutes, I will get back to you. And I'll switch my camera up for a couple of minutes to get to drink some water. Okay, so now what I'm going to do, instead of creating 3 reports, I will eventually create 2 reports. But one report going to consist of 2 presets. One is the data quality and data drift report. It makes sense to bundle them together because it give you an impression how your data looks like. And it also require only, let's say, input features. They don't need any targeted predictions. And then for the target drift, I'm going to keep it separately. So that's what I'm going to do right now. So I would call it registration, let's say data. I would call it data report for now. So report, metrics, and then I pass the list. So first one is this data quality preset, and another one is data drift preset. In the meantime, I just opened this for you. This is just a link for the documentation of evident AI, and it's about which type of data drift algorithms are used. So it's literally showing that for small data with this amount of observations, you get, for numerical, it's two-sample Kolmogorov-Smirnov. For categorical, it's chi-squared test. For binary, it's difference test. And then for larger data with more than 1,000 observation, you got for numerical Wasserstein distance, and for categorical columns, a numerical with a unique Jensen-Shannon divergence. And then you have this threshold, which is set up, but you can customize it eventually. So getting back to here, so what I'm doing right now, I created this data. I call it data report, which consists of 2 presets, and I need to run it. So we have this direct data report run, and for this run, reference data. So I'm using housing, right? So it's housing reference input data. Then you have current data. For current data, it will be housing car input data. And then we have column mapping. You have this regression. Oh, what it was? This was regression column mapping. Okay, as for this one, and now for the target drift, let me just do it here. So let's call it target drift report. We generate again report metrics, and the metric will be target drift presets. So that's what you get out of the box, and I need to run it. Target drift report run, and I need to pass the proper data. So for reference data, I need housing reference data. For current data, I need housing current data, and then for the column mapping, I need my regression column mapping. Okay, so they just run it here. Great. Now we need to show them. So let's put here reg data report show modes inline. So let's take a quick look at it. Up. Yeah. Okay. It doesn't look really nice, so I would prefer to save it. Yes, it doesn't look really nice for regression tasks. So let me just. However, no, look, no, it's pretty good one. Okay, so again, you got this your dataset summary. Then you get per feature. We have more features with this dataset. And you see some dataset. This doesn't look really nice, so I prefer to see it's in HTML. Yeah, let's switch to HTML because that's not so really nice. Okay, so then I will just save this data report. To save the time, I just save it as HTML. You know how to do it in JSON right now, I do hope. So let me put it here and call it reg data report. And for the target drift report, I also gonna save it HTML and gonna put here. So let me just quickly take this one and run. Okay, so now what I want to take a look at, I want to look at reg data report, and then I need to take a look at this reg target drift. Okay, so let me get back here. Okay, this is our combination of data quality and data drift. So you have for each feature, log scale or linear scale. Then you have, okay, there are no missing values. Then you have dataset correlation metric, data sift. Yoo-hoo! It says drift detected. So you see drifted columns, and it shows you exactly in which column it was detected. So you can literally explore it further. And you can also see the data distribution, and you see exactly that's your the current, and that's the reference. So definitely something happening with average occupancy of the room. That's something that we need to investigate. And for the rest, for now, let's say the data drift is not detected. And now let's take a look at this target drift for now. So this is what you get for targets. You see data drift data distribution. It says data drift not detected, and it shows you which method was used. And then you have column targets, and you have correlations for column targets. So you can play around with it. Drift and column prediction is not detected. Although I would say it doesn't look still, oh, because of the drift score. So if we're gonna pass the threshold, probably we're gonna see different results. And there are, again, some correlations that you can see, and also get your target prediction behavior by feature. So you have this prediction was all this goodness out of the box. Okay, so let's sum up this part. Drift detection is pretty hard task. So it's not an easy task. And there are different types of drift. There are three main buckets. What you're going to look at, it's going to be monitoring of the data drift. So literally input of the data in your model. There will be output of your model, and there will be as well something happening to your model. So there are different algorithms which are used based on whether it's categorical or numerical values, based on the amount of samples, which is chosen by default for this preset by evidently. From my own experience, I usually work in tandem with data scientists because they have more knowledge about the model and how does it look in the majority of the cases. When it's about model performance, they are pretty really good with doing anything, let's say NGP notebooks, all this comparison. Although these reports save their time, but when it comes to this data drift part, especially for data drift, which gives a lot of immediate, really important feedback for data scientists. Because if we see that the model performance degrades and we see a huge change, we see the data drift is there, it saves you a lot of time of an investigation. If you don't have this data drift in place, you will have no clue what exactly causing this issue. But now, based on this report, you can immediately see that this feature which has to be investigated. There is another thing with outliers as well. For example, in your code logic could be something that gonna literally drop out outliers. And this is something also to watch out for, because in case you're gonna drop out outliers and then you end up with having almost half of the data set that are outliers, probably something going on with data as well. So that was we were all doing. It was more about development of the model and more about when something happened and something is triggered, then the report could be quickly generated to understanding interactively what's going on. So it's food for thoughts for data scientists. The question is for those who are mostly responsible for model deployment and model monitoring, how to do it without all this HTML, because usually it's kind of a pipeline that has specific steps. And during this pipeline execution, we could introduce the concept of test. So the last piece that we have today, we have not a lot of time left, so I will briefly round up, and your home task will be, guess what, exercise number 4 is to try out the test-based test suites for the regression. I will cover the classification part. So the test-based monitoring, this is what I usually use. And this is literally a checks which allow you to say whether the test is failed or pass. If pass, everything is okay. If test failed, it means that something happened. For example, the data drift happens. That's why the test failed. It also could give you error if there is something wrong with the test. It's a different type of error. So by default, when you expect to run something and generate, for example, the model, generate the model predictions, then this is really nice tool because you know exactly whether everything is great with your data, whether everything is great with your model. And this is something that could be used as a part of the pipeline, and it could be orchestrated. I usually work really often with Airflow as an orchestrator. So it's a really nice step in the Airflow to run specific test, which gives you, for example, if this amount of tests which are really important failed, which means that the alert will be sent to you. And this is really nice because out of the box, you get as well set up a preset for you. So let me show you them quickly. This is how does it look. So there's more information about the test. What is the test? Test suite and test preset. So literally test is just a small piece that verifies something, checks something. Then it's bundled up in a specific test suite. And we have out of the box preset. Today we worked with reports and metrics. And we used out of the box preset with metrics, and now we're switching not to reports but to test suite, and test suite gonna use different presets. So that's an option when you can run it. That's kind of test suites that's out there. You need to be cautious because for regression and for classification there are different type of tests because based on the type of classification. So what's happening here? We created the test suite. So before it was report, now it's test suite. And then before there was metrics, now it's test. And then you just literally download specific presets. In this case, there's no target performance test preset, data quality, data stability, data drift, and multi-class classification test preset because we're working with Iris model. Then to run this test, you need to pass reference data and current data, so what you're trying to compare to, and the column mapping. So let me just run it quickly. And you will see how does it look like. I also save it as HTML. Okay, so it's not what I want to see. Let me just open it. So class test suite. Still to have the visual part. Class test suite. I will just show it here. How does it look like? So this is what you get, and you see that you have 67 tests, from which 54 is success and 13 fail. So what you can do, you can or scroll and you see whether something happens, or you can do a simple way. And here there's a possibility to do specific group by, in this case, by test status, feature, test group, or test type. So you can do it right now by, for example, test status. So I'm not so interested in the tests that are green because they are passed. I'm really curious what's going on with failed test. So let's check. So, and it shows you exactly what kind of failed test. So all tests, it's a presets. You can also customize this presets, setting up specific thresholds, setting up specific ranges. And for example, we've seen what's going on here. For Petzoland, we got out of range values. That's why our test failed. And it shows you then exactly what's going on here. Okay, then let's take a look, for example, share of the most common value. And it's defined the specific threshold that you have again. Yeah, and give you current value counts, duplicate rows. Duplicate rows is 0, okay. And here we have the test threshold, which is literally looking for specific duplicate rows. Number of rows failed because the test threshold is this, and we have 45 rows. Yeah, so this is kind of the way, this is kind of the way how you can use it. Let me go back here. So literally, what I'm gonna ask you to do, of course, to run the test suite for yourself for exercise 4, but we have only 6 minutes left, so I will leave you for your homework. Don't worry, there is a solution folder here. Please look at it only after you've finished the exercise to make sure that you get value from it. And here, when you do it, make sure that you import regression test preset, because so far we had only multi-class classification test preset. So let's sum up this part. Task-based monitoring with Evidently. This is the way to use Evidently in production, how the setup could look like. For example, there is specific, for example, your model deployed in a batch way. So literally at 6 o'clock in the morning, there is a specific job that extracts the data from some point, deliver this data to model transform this data, make predictions, and these predictions is then go to where they have to go. So in this case, for example, if it's orchestrated by Airflow, you can include the specific test suite. You can define specifically what do you want, or you want to watch out for data drift, or you want to watch out for a target drift or a data quality. And this is what exactly gonna be done. So in case the test failed, which is pretty important one, based on how your monitoring system will be set up, you get a notification on alert. And this is for you will be the next step, or to go further with generating reports and investigating in an interactive way what's going on, or there will be probably other options to do it. So that's what we discussed today. So we take a look at Evidently library. We take a look at the way of measuring model performance for a regression classification task, and the way how to generate reports. Then we take a look at handling different types of drift. So we are looking into the data drift and target drift. And then we round up with this test-based monitoring, which is more production story, which literally they look the same, even the name will be the same. You will have like data quality report, data quality report preset, data quality test preset. It will be, let's say, sounds like this. And this is what you're going to use, let's say, for production model monitoring. And for the closing remarks, today we get only the first introduction into the handling drift of models. So if you want to know more about customization of it, or you want to know more about how to create my own metrics, can I create my own tests? Yes, it's possible. And we can, if you're interested, we can spend time on it later with the follow-up workshop, for example. Or if you're interested how to integrate Evidently with Grafana, which is literally, let's say, like a dashboard, or Airflow Orchestrator, or MLflow, if you're using this for model registry, for model tracking and experimentation validation, or usage of Metaflow. So if you're interested in it, let us know, let us PyLadies Amsterdam know, and we can set up next year more in-depth workshop for you. So, of course, Evidently is an open source library, which means they are looking for contributions. So if you're interested in contributing to Evidently, there are these guidelines, and I literally, what I do, wait a second, I will just post it here. Yeah, it's literally, if you want to contribute to Evidently, here more information how. I'm just passing it here to the chat. So if you want to contribute to it. And I think that's it for now. Thank you so much for this time together. I do hope that you learned today something valuable for you. And literally, this is it for this year. For the next year, we already have January and February planned. So for January, it will be more going on and investigating Django REST framework, and it will be online events. And for February, we're going to have a joint event with another community, and it will be a hybrid event in the center of Amsterdam. I think that's it from my side. Any questions? We have the last minute left. Time is yours. Floor is yours. And I think I now can stop sharing my screen. I stop sharing, right? Good. Okay. I think Bhumika, it's time to stop live streaming.
Thank you all for joining, and see you at the